Okay, well, now that we stole from the blind and the poor, all we have to do is just escape over that barrier of fire.
How fast do you think we need to go to jump that fire? Obviously considering that air resistance is negligible. Oh, I wish there was some sort of physics hero to solve our problem for us. Don't worry, Physics Man and Quantum Boy are here. Just relax and state your problem.
We need to know at what velocity to travel in order to jump over that barrier of fire down there.
Air resistance is negligible. Right. Okay. I think this is similar to that 1988 physics problem, the AP one. As I recall, only a mere 30% got this one right.
Well, have no fear, Quantum Boy. We can solve it. Start calculating. Go! 2.037 meters per second.
No, we need feet per second.
Right, Quantum Boy. What is the conversion factor?
They need to go 6.68 feet per second.
Thank you.
Right. Thanks, guys. See you later.
No problem, little yellow man. I'm glad I could help you in your time of terror.
Right. Here's how we solve the problem. The problem we encountered with the two Legos in the car was a simple projectile problem. We needed to do the problem in meters because the acceleration we would use due to gravity was 9.8 meters per second. So, we knew that they were 9 feet from the ground and they were 5 feet away from their barrier of fire. So we decided to change that into meters. They were 2.743 meters away from the ground and their barrier was 1.524 meters away. First, we set up the problem and split the problem into horizontal and vertical components. So, we decided to do the vertical component first with the acceleration downward at negative 9.8 meters per second in order to figure out what the time it took to hit the ground was. We used the equation y equals y sub 0 plus v sub 0 t plus 1/2 at squared. With simple plug and chug from there, as we set up the equation to equal that t would equal the square root of negative 2.743 over negative 4.9, which was 0.7482 seconds. Using that time, we decided to plug it into the horizontal component of the equation, which would be v is equal to x over t. Plugging into that, we figured out that the velocity, minimum velocity it would take to clear that fire would be 2.037 meters per second. We, of course, had to change this back into feet because the Legos only know feet. So we plugged that into the conversion factor and came up with 6.68 feet per second as the minimum velocity it would take to clear the barrier of fire.
Oh no! No, please!
Don't worry, Physics Man and Quantum Boy are here.
You have to say that every time we do a problem.
Yes, I do.
Okay. Lego Man, state your problem.
We are dying in this bucket. What do you think is happening?
But I don't understand. What do you want?
To live!
Oh, right. Quantum Boy, start calculating his life expectancy.
Well, seeing as the rate of decay of plastic is
Wait!
just
I think they're in danger. We should help them.
Right.
There's water going into that bucket, and they could possibly drown.
Right.
Stay there, Lego Man, and tell me, how fast is the water filling up?
I don't know. Like in the last 30 seconds, it has filled up an inch.
Right. Okay. You're still in danger.
You're right.
Right. Let's calculate how long until they drown.
What?
I said let's calculate how long until they drown.
Oh. Right.
Start calculating. Calculator, come! You have 7 minutes till you drown.
Okay, well, what do I do? I have no clue.
Wait, what is your density?
I don't know.
Don't worry, we'll find it.
Will he float, Physics Man?
Nope. We're glad to have served you today. And wait, no need to thank us. We're just doing our job. Quantum Boy, I think it's time to move to the next question.
But first, here's how we went about solving this interesting dilemma. Given that in the last 30 seconds, the bucket had filled up 1 inch, we made a rate out of it, 0.0333 inches per second. We're also given that the radius was 7 inches, the radius of the base, of course, and we decided to plug that into the area equation to find out the area of the base, 49 pi inches squared. We then, to get the flow rate, we multiplied the area of the base times the rate we'd gotten from what the Legos had told us. This came out to be 5.13 inches cubed per second, a flow rate. Then to get the time it took for the bucket to fill up, we took the height, 14 inches, and divided it by 0.0333 inches per second to get 420 seconds, or 7 minutes. 7 minutes until the bucket would fill up.
Many times, or will they do it? They're taking what's mine, and they tell me that I blew it. What can you do?